Hey everyone, in this video I'm going to discuss package management in Ubuntu. So by the end of this video, hopefully you'll learn how to install packages, delete and remove packages, search for packages, and hopefully you have a solid understanding of what's the difference between using like DPKG versus a package management system like apt, as well as understand how to configure and set up new repositories. All right, so let's get started. The first thing I want to discuss is what exactly a package is. So a package is a group of files that make up a software application. Files included in a package include installable scripts, config files, library files, and documentation. So now that we've defined what a package is, I want to talk about an important concept called dependency. So a package may require the presence of other certain packages in order to be installed successfully, and thus a package is dependent on those other packages. To avoid running into any dependency issues, Linux comes with a package management system that handles installing, removing, and changing packages, as well as handling all the necessary dependencies for you. So if you want to install application 1, which has a dependency on application 2, the package manager will be intelligent enough to know that that dependency exists, so that when you install application 1, it'll also automatically install application 2 for you to handle that dependency. Now, the final thing I want to define is what a repository is. So a repository is a digital library for storing software packages. So think of it as a massive collection of applications, and when we want to download and install a specific application, we just look for it in the repository and download it from there. Now, repositories can exist anywhere. There are numerous repositories available on the internet. Additionally, you can even have your own repository stored locally. A good, metaphor to better understand what a repository is or how it works, think of it like the App Store on a Mac. Okay, so it's a place that all your applications or all potential applications for you to download and use exist, so that you only have to go there. You can search for whatever package or application you want on the App Store and then download whichever one you want. So it's just a really convenient way to organize and store all of your potential applications that you can download or use, instead of going to each individual site and basically looking for a specific application. Now, the first command I want to start off with is called dpkg. So dpkg is the command that we use to install, query, and remove packages. But I want you to understand, before we start going over these commands, this is not the best way to do it. We're going to discuss later why it's not the best way to do it and why there's a better solution, but it's important to understand how to do it because it's still a fundamental skill. And by doing it, I can show you what the flaws are of this command and why there's a better alternative. Okay, so to list all the packages that are currently installed on your machine, all we have to do is dpkg-l. Okay, and that's going to show you every single package that we've got installed on our machine at the moment. And if you want to display the details of a specific package, we can do dpkg-p and the name of the package. So as an example, we can do python 3, and it's going to give you a more detailed view of that specific package. If we want to see if a specific package is installed, we can use the dpkg with the -s flag and then the package name. So if we do python 3, we can run that, and we can just look for the status section, and it says it's installed. So that's just a quick way of seeing if a package is installed. Now I want to go ahead and show you guys how to install a package using dpkg. So to do that, let's go ahead and find a .deb file. So all Ubuntu packages are going to be .deb files. So they're the equivalent of like a .exe file in Windows, because when you download an application and you want to install it, you'll just click on that .exe file and it installs. You can think of the .deb file as the Ubuntu equivalent. So there's plenty of places we can find these packages. We can find them using repositories, or we can just go on the internet and search for it. So I'm already at the page here, but if you wanted to just search Ubuntu packages, and it's going to take you to the Ubuntu package search, and just go to the search field here and search for whatever package you want. So what I'm going to do is I'm going to look for a package called fping. If you don't know what fping is, it's very similar to the regular ping utility, but it allows you to ping multiple hosts at once. So if we search for fping, we've got a hit here, so just select that. Then these are going to be the download files. So you can see here that there's a download file for each of the different architectures. So we need to find whatever architecture our system uses and then find the corresponding file. So to figure out what architecture your system uses, do dpkg --print -architecture. Okay, so it says that we're using AMD64. So just select AMD64, and then you got the different mirrors for where you can download it from. So we can just click this and it's going to download, or we can use the wget command, which basically allows you to download files off the internet and then just provide it the link. So we do wget and then paste that. It should have downloaded the file. So if we do an ls, we can now see we've downloaded the fping utility. All right, so we have the .deb file. If we want to see information about this specific package file, we can do dpkg --info and then fping, and it's going to give us information about this package. Okay, so to install it, we just do dpkg -i, and then we provided that .deb file. And we need root privilege, of course. Okay, so it has finished installing, and we can actually run the command for fping using fping --interval. We'll just do =1. So I'm just going to ping myself. This is just to verify that we successfully installed the package. So fping is working, which means we have successfully installed the fping package. Now, the next example I'm going to show you is going to really show you why we don't want to install packages using DPKG. Okay, so let's say we want to download Apache. Okay, so Apache is basically a web server. It's a application So Apache is basically just a web server application. So let's go back to this search and let's search for Apache. So we've got a hit here, and remember we use the AMD64 architecture, and we can do the same thing, copy the link location, or we can just download it and save the file. All right, it's finished. It should be finished now. Okay. So let's go back here and let's see, where is it? It's probably in downloads. All right, so this is where it is. And let's try dpkg -i and then the file. There you go. We need root access. And if you see, now that we've run the dpkg-i with the Apache file, we get a bunch of errors. And the errors give us a little information as to what went wrong. And you can see here, dependency problems prevent configuration of Apache 2. So Apache 2 depends on Apache 2-bin, as well as Apache 2-data and Apache 2.utils. So basically what this is telling us is that for Apache 2 to work, we need to have all these packages, Apache 2-bin, data, and utils installed, or then Apache 2 will not function right. And that's the fundamental flaw with just using DPKG, is that it's not intelligent enough to know that we need to install these extra packages for Apache 2 to work. It knows that it didn't work, but it doesn't automatically fix the issue for us. And if you recall earlier when we were talking about package management systems, um, package management systems, unlike DPKG, will automatically handle these dependencies. So if you use a built-in package management tool, it should theoretically install, it should know that we need these packages, and it will go ahead and install them for you so that we can install Apache 2. And that's significantly easier than manually going and finding these files or these packages and then doing a dpkg on these, and then finally getting to Apache 2 and then doing a dpkg and installing that. Because what if Apache 2-bin has further dependencies? And then what if those dependencies have further dependencies? You can get stuck in this loop of just installing one dependent package after another. So that's why you always want to use a package management system. So the built-in package management system is called apt-get. So apt-get will handle the installation of a .deb package on a Debian-based Linux distribution. And remember, a package management system is just a set of tools that will help you install, remove, and change packages easily while also handling any dependency issues. The apt-get command, or the package management system, technically actually uses the dpkg command under the hood, but it has the extra abilities of being able to resolve the dependencies. All right, so the first two apt commands that I want to show you guys is apt-get update and apt-get upgrade. All right, these are the first two commands that you should always run on your system. And they're two of the most important commands. And let me quickly go over what they are and what the difference is between the two of them, because this does lead to some confusion. So we have apt-get update. And I do want to point out that anytime we run these apt-get command with, whatever option of update, upgrade, install, or whatever, in newer Linux versions, we don't actually have to use the -get. We can just go ahead and remove that and just put an apt. But you can use whatever method, or if you're using an older version of Ubuntu, you're probably going to need the apt-get. But any recent versions, you can just leave the -get off. Okay, so we have apt update or apt-get update, whatever you prefer. And then we have apt-get upgrade. So let's go over what these two do. So what apt-get update does is it downloads a package list from all the repositories configured in the /etc/apt/sources.list folder, and it updates them to get information on the newest versions of packages and their dependencies. So think of it like think of apt-get update as the equivalent of using an application in Windows and then clicking that button that says check to see if there's updates. So that's all apt-get update does. It checks to see if there's updates. It doesn't actually update anything. All right, so the next command, upgrade, apt-get upgrade, will look at all the locally installed packages and applications existing on the machine, and it'll fetch the new version of the packages if an update is available. So it's used to update all installed applications to the latest version. But the problem is that for it to actually perform the upgrade, it has to know about the newer versions. And how does it know about the newer versions? By checking the database, which gets updated by the apt-get update command. So the update will update the databases, letting the system know there's updates, and then we can go ahead and then install those updates using the apt-get upgrade. But if we just run the apt-get upgrade command, he doesn't know about the updates, and it'll end up saying that there's no actual updates to actually install. So that's why, remember, you'll always have to do apt-get update, then followed by an apt-get upgrade. So what a lot of people like to do is they'll actually string those two commands together, and you can run two commands at once using the two and signs. So do sudo apt update, and then we do and sudo apt upgrade. So this is what they do usually. It basically will run this command, then once it's finished, it'll then run this command. So this way they can just knock it out with one command. And usually they pass in one parameter, which is the -y for the sudo apt upgrade command. And why they do this is because when you run the upgrade command, it's going to tell you, or it's going to prompt you and say, hey, these are the upgrades we want to install. Is it okay to install it? And you'll have to hit the letter Y for yes to actually go ahead and install it. Usually they already know ahead of time they want to upgrade it. That's why they ran the command. So they just do -y so that they don't get this prompt. And that's super helpful because these two commands can take a long time to run depending on how out of update or how out of date your actual database is. So usually what people want to do is they want to just run this command and then walk away from their computer, maybe go to lunch and then come back and have it finished. But if you don't do the -y, you'll get that prompt and it will never finish installing because it's waiting for you to enter yes in the prompt to continue. So if you do the -y, it'll automatically hit yes to every time it gets a prompt or a question, so that it'll just automatically run on its own and finish, so that way you don't have to babysit it and respond to every single prompt that you get. All right, so I'm going to go ahead and run this. And you can see it's updating all the packages first, and then once it's finished updating, it'll go ahead and then upgrade, which means we're going to install the updates that we found. Okay, so it's finished. It looks like it's finished, but it actually ran into an issue, and it's because it found the Apache application that we tried to install, but it was broken due to the dependencies. So there's a few things we can do to fix this. We can do the its recommendation, this command to fix any broken dependencies. Another way to actually do that is to do sudo apt-get install-f. So this will install all the necessary dependencies. Or what we can do is, since we don't actually want Apache, we can actually remove using the dpkg command. So dpkg, and I forgot to cover this, we can remove packages with dpkg. So to remove a package with dpkg, we do the dpkg-r command. Okay, so that will remove whatever package we provide it. So if we do dpkg-r and then the name of the package, it's Apache 2, this will remove the package. But there's one more option when it comes to removing packages. We also have the p. The difference between R and P is that when you do -r, it'll remove the package, but it'll keep the configuration files. But if you want to also remove the configuration files for that package, you have to use the -p, and that's a capital P, just to make sure you guys understand. So use whichever one you want. If you want to save the configuration files just in case later on you want to install Apache again and keep those configurations, do -r. If you want everything gone, just do -p. So we're going to do the -p and remove that package. Okay, so now it is removed, and it should be good to go. But also keep in mind that if we wanted to keep keep Apache, we could have just run this command to fix any of the broken dependencies. And this is a command you can run at any time to fix any broken dependencies. But let's go ahead and run this, and let's just see if everything is good to go now. All right, it's finished, which means we have now updated and upgraded all of our installed applications. The next thing I want to show you is how to search for packages. And when we search for packages, you have to remember where we're searching, and that's our repository list. So if you remember, a repository is just a place either on the internet or locally that stores a bunch of different applications that you can then go ahead and download and install. But your Ubuntu system has to know where these repositories are, and the configurations on how to actually configure a repository for us to point to is in the /etc/apt/sources, actually just apt and then we have the sources dash list. So if we cat that, you can see that this is an example or a configuration of a repository. So this is the actual location. This is going to be the version. Don't worry about what universe or main or restricted mean, or what deb-source means. I'll cover that later in this video. Just mainly remember that this is the location, so that when we go to actually install an application or search for an application, it's going to check one of these links. And we've got more than one repository configured. We have this one. We also have this one configured. We have this one configured. So we've got a couple of repositories configured. So when we search for an application, we'll check all of those. And what those really are just servers. They're servers that just contain files. So if we click this, I wonder if I can, let me copy that link, go into Firefox. If we paste that link, sorry, that's not the link I wanted. Let me grab this. No, not that link. Here, I'll grab this link. You can see it just takes us to a server, and this server has a certain directory structure with the different packages. But remember, it's just a server that just contains all these files for us to download. That's all. That's all it's really doing. And there's really nothing else to it. That's it. Okay, so now that you guys understand, where we're searching for applications, if we do a apt-search, apt-cache search, we can then search for a name of an application. So let's say we want to download the htop application. So if we search for htop, it's going to search all of those repositories that are configured here, not just one of them, all of them, and it's going to look for a package with the name of htop. So we've got a few extra hits on top of the main one, but this is what we're looking for, htop. And we can also do an apt-cache search Apache 2, and you can see we actually get a lot of hits for that. But let's go ahead and install an application using apt now. I've showed you how to upgrade and update and upgrade. Now we have to actually install a package. So to install a package, we do apt-get install and then the name of the package. And you'll need root privileges as well. And just like we did with the upgrade command, we want to make sure that the database of our repositories is up to date. So we want to make sure we know what the latest packages are available and the latest versions. So we actually have to run an apt-get update before we do an apt-get install. Because if you don't do the update first, we may not be installing the latest version of the application, and we could get an older version of the code, which we don't want. So you always want to update the database first and search for the latest version of the application by doing an apt-get update and then an apt-get install. So let's do sudo apt-get update, and then we'll do the same thing. We'll just run this all in one line. We can do sudo apt-get install, and then let's say we want to install Apache 2. And you don't have to do this all in one command. You can just run this command, and then once that's done, run this command. But I like to just do it all in one command. It's quicker. And then I always like to do the -y so that it doesn't prompt us and ask us if we're sure we actually want to install the application. So go ahead and run that. All right, it's completed, and you can see it's thrown no errors because the apt package manager was smart enough to know to install all the dependencies it needed so that Apache 2 can function okay. And that's it. So we've got a working Apache application running on our system. Well, it's installed. I don't know if it's running at this point. But that's how easy it is to use apt, and that's why it's always recommended to use apt instead of just manually downloading and installing individual packages using DPKG. Okay, so let's say we didn't want to download the latest version of an application. Let's say we wanted to download a specific version. We can do that with the sudo apt-get install. Then we put the name of the application. So let's say Apache 2. Then you put equals, and then you put the version number. So you would put, whatever, like 1.7.5 or whatever the version number that you want to download, hit enter, and it should download that specific version. Now, if you don't know what the available versions are for a specific application, we can actually run a command to find out what available versions there are for a specific application. And that's going to be apt-cache policy Apache 2. So these are the different versions that are available that we can download. Now, to remove a package, all we have to do is, to remove an application, just do sudo apt-get remove, and then the name of the package, so Apache 2. But just like with DPKG, there's two different options actually. We can do remove, or we can do purge. The difference between the two being remove will keep the configuration files. Purge will also delete the configuration files. So just do whichever one you want. I'm going to do purge to remove the configuration files. I don't need them. And it's going to ask me, do I want to continue? Just hit yes. All right, and now it's removed. But there's one slight issue. When removing packages with apt-get remove or apt-get purge, the package target will be removed. However, the dependencies that were automatically installed, like Apache 2-bin, in order to fulfill the installation requirements, will still be left installed on the machine. In order to remove any packages that were installed as dependencies that are no longer required by any other packages, you have to actually run a specific command, which is sudo apt-get auto remove. But once again, with this command, there's two options. We can keep the configuration files for those packages that were installed due to dependencies, or we can go ahead and delete the configuration files as well. So if we just run this command as is, it will keep the configuration files. If we want to remove the configuration files, we have to do --purge. Okay, so I'll run that. So it's going to delete those dependent packages as well as the configuration files for them. Now we've got quite a few programs installed by default. If you want to see detailed information for a package that is available in one of your repositories, you can use the apt-cache command, apt-cache show command. So if we do apt-cache show, and then we can do like fping, it's going to show us detailed information about that specific package. And one other command I want to show you, and we actually already discussed this, but if you want to fix any broken dependencies that you may have, like if you had used the dpkg command, you can just do the sudo apt-get install -f. So that's going to fix any dependency issues you might have on your system. Now, software in Ubuntu repositories are divided into 5 categories. We've got main, universe, multiverse, restricted, and partner. So I want to go over what each of those mean and what they're used for. So first off, let's start off with main. So main, when you install Ubuntu, this is the repository that's enabled by default. The main repository consists of only free and open source software that can be distributed freely without any restrictions. So software in this repository are fully supported by the Ubuntu developers. And this is what Ubuntu will provide with security updates until your system reaches end of life. The next section, which is universe, This repository consists of free and open source software, but Ubuntu doesn't guarantee of regular security updates of software in this category. So software in this category are packaged and maintained by the community. The Universe repository has a vast amount of open source software and thus enables you to have access to a huge number of software via the apt package manager. The multiverse contains software that are not free and open source. And due to licensing and legal issues, Ubuntu cannot enable this repository by default and cannot provide fix and updates for them. It's up to you to decide if you want to use multiverse repository and check if you have the right to use the software. Now, restricted, this section, Ubuntu tries to provide only free and open source software, but it's now for the restricted repository, usually Ubuntu wants to try and provide free or only provide free and open source software, because that's really the main benefit of Linux, is that it's free, it's open source, anyone can use it, anyone can take a look at the code, but there are times where that it's just not possible for them to provide free and open source software, and there's special circumstances when that happens, and that's usually when it's dealing with supporting hardware. So the restricted repository usually consists of proprietary drivers. Okay, and then the final section, which is the partner section, this repository consists of proprietary software packaged by Ubuntu for their partners. So now that we've covered the 5 different categories for Ubuntu repositories, let's go take a look at how to configure a new repository. Now, if you remember, the repositories are configured in this /etc/apt, and then the sources list. So if we just cat that real quick, once again, you know, this, let's go to the top. It's usually going to be the main repository. So you can see here, this is the structure of a repository entry. So we have DEB, then the location of it, then Bionic, and that's the code name for the version I'm running. So I'm running 18.0.4, so that's going to be Bionic. If you're running a different version, it's going to have a different code name. Then we can see the repository type, which is main and then restricted. So that's what's going to come installed by default. So we're always going to have this enabled by default. But if you want to create a new repository to include, you know, maybe you want like a partner repository, or maybe you have a repository that points to a completely different location, you just have to keep to this same exact structure where you're going to have DEB. You can also have DEB-source. Now the difference between the two is the DEB line represents binary packages that you can install with apt, but DEB-source are relative to source packages. So source packages are needed only if you want to compile the packages yourself or inspect the source code for a bug. So ordinary users will not use the DEB-source. It's primarily used for developers only. Then you have the location of the repository. So this is the server that actually contains it. Or we could even have a repository local on this machine, and we just point to the directory path to that repository. Then we provide our version name, and then we include if it's main, universe, multiverse, or whatever, and we can include multiple ones of these as well. So that's the structure of a repository entry. You can add it straight to this line by opening it up in VI or Nano and just adding it. Or what we can also do is we can go to the sources.list.d directory. You can see here there's nothing here, but we can make a file. So we can do sudo vi, and then we can call this anything. We'll just say my new repository, and this file has to end in a .list. So that has to be the extension of the file. And then we open that, and we can go ahead and put in new repository entries, and they're going to follow the same exact syntax with the .deb. and then, you know, http:// and then the path, and then Bionic for my version. So that's all you have to do. And then you can just save the configs or close it out. I don't actually want to save this. And that's all you have to do to, you know, configure a new repository. And obviously after you configure a new repository, you're going to want to do a sudo apt-get, a sudo apt-get update, so we can update our database so that we learn about the new packages that are available in that new repository that we just configured. And there's one other way to actually configure a repository, and this is probably a little easier for most people, so you don't have to mess around with files, is you just do sudo add-apt-repository. And then you can provide the same exact configurations. You can do, you know, db and the path, you know, blah blah blah.com, whatever, and then, you know, Bionic and whatnot. So it's the same exact thing as actually putting it in the file, but you can also use this command and have your repository installed. So that's all I had for this video. There's still more to cover with package management, but I can't cover everything. But hopefully you guys found this video helpful, and there'll be plenty more videos to come.